Dear students, now we are going to see the subject renewable energy system, and that the topic is solar radiation. Solar radiation is mainly classified into two types: extraterrestrial radiation and terrestrial radiation. In generally, this solar light intensity is keeps on attenuating while it propagates from the surface of the sun, though the wavelength remain unchanged. Here, in solar radiation incident on the outer atmosphere of the Earth is known as extraterrestrial radiation. The extraterrestrial radiation deviates from solar constant value due to two reasons. The first variation is the radiation emitted by the sun itself. The variation due to this reason, variation is less than plus or minus 1.5% with different periodicities. Second variation is the Earth-Sun distance arising from Earth's slightly elliptical path. This variation is about plus or minus 3% and is given by the extraterrestrial current I extra is equal to the solar constant 1 plus 0.33 cos of 360 n divided by 365 watt per meter square. Extraterrestrial radiation is outside the atmosphere and it is not affected by the changes in the atmospheric condition. While passing through the atmosphere, it is subjected to a mechanism of atmospheric absorption and scattering depending on the atmospheric condition, depleting its intensity. A fraction of scattered radiation is reflected back to the space while remaining is directed downward. Solar radiation that reaches the Earth's surface after passing through the Earth's atmosphere is known as terrestrial radiation. The terrestrial radiation expressed as energy per unit time per unit area, that is watts per meter square, is also called as solar irradiation. The term solar insolation, that is incident solar radiation, is defined as solar radiation energy received on a given surface area in a given time, that is kilowatt per meter square. The position of extraterrestrial and terrestrial regions are indicated in the figure. So that is the outside the atmosphere, that is the extraterrestrial region. So within the atmosphere, that is the intraterrestrial region. This is the surface of the Earth. This represent the scattering of sun rays, and some of the rays are absorbed by the absorption in the atmospheric particles. Depletion of solar radiation. The Earth's atmosphere contains various gases constituents, suspended dust and other minute solid and liquid particulate matter. These are air molecules, ozone, oxygen, nitrogen, carbon dioxide, carbon monoxide, water vapor, dust and water droplets. Therefore, solar radiation is depleted during its passage through the atmosphere. The different molecules do different things. Absorption. The absorption radiation increases the energy of absorbing molecule, thus raising their temperature. Nitrogen, molecular oxygen and other atmospheric gases absorb X-rays and extreme ultraviolet radiations. Ozone absorbs a significant amount of ultraviolet radiation in the range of less than 0.38 micrometer. The water vapor and carbon dioxide absorb infrared radiation in the range of greater than 2.3 micrometer and deplete to some extent the near infrared radiation. A dust particle and air molecules absorb a part of solar radiant energy irrespective of wavelength. Scattering. Scattering by dust particle and air molecules involves redistribution of incident energy. A part of scattered radiation is lost to space while remaining is directed downward to the Earth's surface from different directions as diffuse radiation. The scattered sunlight makes the sky blue. In cloudy atmosphere, a major part of the incoming solar radiation is reflected back into the atmosphere by the cloud. Another part is absorbed by the cloud. The rest is transmitted downward to the Earth's surface as diffuse radiation. The energy is reflected back to the space by reflection from cloud plus the scattering by atmospheric gases and dust particle. The reflection from Earth's surface is called albedo Earth atmosphere system and has a value of about 30% of incoming solar radiation. Thus, the surface of the Earth have two components of solar radiation, that is direct or beam radiation, unchanged in direction, and diffuse radiation, the direction of which is changed by scattering and reflection. The total radiation at any location is the sum of beam and diffuse radiation. This is also known as a global radiation. The beam radiation is also called as solar radiation. It is propagating in a straight line and received at the Earth's surface without change of direction. That is in line with sun is called beam or direct radiation. Diffuse radiation, that is the radiation scattered by aerosol, dust and molecule is known as diffuse radiation. It does not have unique direction. Global radiation, the sum of beam and diffuse radiation is referred as total or a global radiation. Measurement of solar radiation. The solar radiation data can be measured by different instruments, that is pyranometer, pyrheliometer, sun-sign recorder. So pyranometer is used to measure the global radiation by using a horizontal surface, but it can also be used in inclined surface. Pyrheliometer is an instrument. It measures the beam radiation by using a long and narrow tube to collect only the beam radiation from sun at normal incidence. Sun-sign recorder measures the sun-sign hours in a day. Pyranometer, the diagram represents the pyranometer. It consists of a thermopile whose sensitive surface responds to the radiation of all the wavelength, and it measures accurately the total power incident on it. It consists of a circular blackened hot junction and exposed to sun. That the hot junction is exposed to sun and the cold junction are completely shaded. The temperature difference between the hot and cold junction is the function of radiation falling on the sensitive surface. The sensing element is covered by two concentric hemispherical glass dome to shield it from wind and rain. This is also reduce the convection current. The instrument has a voltage output of approximately 9 microwatt per meter square and has an output impedance of 650 watt. The pyranometer provided with a shadow band to prevent the beam radiation from reaching the sensing element, measure the diffuse radiation only. Many inexpensive instruments are also available for measuring the light intensity, including the instrument based on cadmium sulfate photocell and silicon photodiodes. This instrument gives a good indication of relative intensity, but their spectral response is not linear and thus cannot be accurately calibrated. Pyrheliometer. The normal incident pyrheliometer that's shown in figure, it consists of a long collimator tube to collect the beam radiation whose field of view is limited to a solid angle of 5.5 degree by appropriate diaphragms inside the tube. The tube is blackened to observe any radiation incident at an angle outside the collection solid angle. At the base of the tube, a wire-wound thermopile having a sensitivity of approximately 8 millivolt per watt per meter square. The tube is sealed with dry air to eliminate absorption of beam radiation within the tube by water vapor. A tracker is needed if a continuous readings are desired. Sun-sign recorder. It measures the duration in hours of bright sunshine during the course of the day. It consists of a glass sphere mounted on its axis parallel to that of Earth within the spherical section. The bowl and glass sphere is arranged in such a way that sun rays are focused sharply at a spot on a cord held in a groove in the bowl. The cord is prepared from special paper bearing a time scale. As the sun moves, the focused bright sunshine burns a path along this paper. The length of the trace thus obtained on the paper is the measure of duration of bright sunshine Three overlapping pair of groups are provided in the spherical segment to take care of the different season of the year. Thank you.